Hi, welcome to the Calculus 2 lecture series. And this is our lecture number 5 for the unit number 1, the application of integrations. And this is our last application. We're going to take a look in this unit. And in this lecture, we're going to talk about how to find the average value of a function. I think most of us, we know, if I give you a bunch numbers, and I say, hey, find the value of this, like these 10 numbers. For example, I give you 10 different numbers. I say, hey, find the average value of these 10 numbers. So I think everyone know how to do that, right? You add them together, divide by 10. How about if I have a function? And now say, hey, find the average value of this function over a certain interval. How do we do that? So this is what in this lecture we're going to talk about. All right, so now let's go ahead and go to our lecture note and let's take a look. All right, so for this one here, so for this lecture note, for this lecture, first things, let's take a look. What are we going to, the key concept we're going to cover in this lecture? We have two things we want to cover. So the first thing is just like we talk about, how do I find the average values, right? So how do I find the average value of a function? Then the second thing is we're going to take a look, we call this the mean value theory. Of integral. So you will say, oh, mean value theory. Oh, that sounds very familiar. Seems like in the calculus 1, we did that. We have the mean value theory of the derivative. So now let's take a look at the mean value theory of the integrals. And do they have relations? Well, what did the mean value theory of the integral try to tell us here, right? Okay, so let's add the two concepts, two key topics we're going to talk about in this lectures here. Okay, so the first thing is how do we define the average value of the functions here? So the average value of the functions here, right? So we say the over closed interval, let's say here of a closed interval. How do we define it? Remember that we said if I give you 10 numbers, we know how to find the average value. And now how about I give you a function? How do I find the average value? So, okay, so here's our definitions. See here. So my values here. So this is my formula. So it's f functions. Then I put a indices here. I say average. So it's f of the averages here. I think some people like to use AVE instead of AVG. Okay, so the average here would just be the B minus A, 1 over B minus A, and then you integrate A over B, f of x dx here. So the concept here is basically, we know the integration of so for example, this is A, this is B, right? So if this is my function f of x here, so A over B is just it's just these areas, right? So I'm finding the total area divided by the distance between these 2 points here. So it's kind of similar like the idea, we do the mathematically averages for the numbers here. Okay, so now let's take a look here. So the problem number 1 is to find the average value of this function over 1, 4. So this will be pretty easy. We said the averages here will just be from 1 to 4 is what? It's 3, right? So it's 1 over 3. Then you just take the integration from 1 over 4 to see what is the total area. So this is 2x plus 6x squared dx. So what is the total area, over this intervals here? So in here, we can find that this is 1 over 3. This will be simple integration, so will just be x squared plus 2x cubed. Then you substitute the upper bound and the lower bound. So in here we say it's a 47 here. So we know what is the, so that's the value of the 47th here. Okay, so now in the, so in here we set up, okay, so we said, well, you know, that's pretty easy. So let's take a look at problem number 2. Let's say find the average value of cosine x over 0 to pi. So this is my f of x. So I will say, okay, so the average value for the function is from the 0 to pi. So the length is 1 over pi, right? And then you're integrating the cosine x dx. And so this is from 0 to pi. So this is 1 over pi. So the cosine integration will give you sine. So it's pi. Okay. So that means in here, this will be zeros here. Okay. So now we know how to do the calculation. The mathematical part is pretty easy. So what is this? You know, what is really, this is 0 and 47 means here. So it means, okay, so what is the significance of that? So that's why we are going to take a look at, we call this the mean value theory of the calculus, of the integrals here, all right? So now in here, so what is that? So we say if f of x is a continuous, on the closed interval, AB. So there exists a C, and this C is going to belong to this interval layer, such that AB f of x dx is equal to f of C times b minus a here. So based on this definition, we know if you know so f of the c's, right? So if you move the b minus a over, so this is b minus a, 1 over b minus a, right? So this is ab f of x dx. We just say, what is this value? This is the average values, right? So that means it's equal to f of the c. So what's that means here? Let's try to use a graphing to represent that. So maybe you will see, get a better idea. Okay, so let's see, this is my A, this is my B here. And let's see here, I have a function go like this. Okay, so now let's say that between A and B is here, between A and B is here, right? So let me get the function a little bit more dramatic. So this is that can demonstrate that. Okay, so this is the function f of x. So this is the A and this is the B, right? Okay, so this is the f of A, this is f of the B here. Okay, so now we know let me color coding that for you. So AB f of x dx. That means, let's say, this is the area under. Right, so let's give you the integration. So what is the mean value theory tell you? Let's say, hey, you can find values here. So you can find, so let's say, okay, I can find values, maybe it's in here, okay? Let me try to get a different color. So that means I can find a value in here. So for this values here, so this is what I called is the C values here. And of course, this distance is f of c, right? So it will tell you, let's say in here, if you do like this. Okay, so now, use the f of the c and you do a rectangles, right? So basically they tell you, you'll be able to find a value f of the c. So if you calculate, so take a look, this is c, is the height, right? F of c is the height for these triangles. So the f of c, so the f of the c times the b minus a, what is this? This is the area of this triangle, this rectangle, right? So it will be just the rectangle of this pink rectangle. That's what we mean that the mean value series of the integrals here. So let's take a look at here. Find the average value. So basically, why is the average value here? It's 0. So you take a look here, right? So this is my cosine theta. So let's take a look at my cosine theta. Is go from here to here, and now is from 0 to pi, right? So this is 0 to pi here, right? So now in here, I know the area. So if you integrate from 0 to pi, so 1/2, half of it is above or half of it is below. So it will be zeros here. That means you can find, so your C point is here, it's right in here. This is my what? This is my f of the c, and then in here you don't really have rectangles, right? Because so that's why it's equal to zeros here. So for this one, it's the same thing. So that means the f of c is equal to 47. You can find the value inside here. So to make sure the area you're integrating will be equal to, the area based on this FC, the rectangle area, just like in here, right? So when I integrating, the function, I will get this yellow areas, right? But then the mean value theory of the integral tell me always, I'm going to have a C, exist a C in between, such that, the C will create a height of f of the C. So when you try to find the the area of this purple rectangle I'm putting here will be equal to the red, will be equal to the area under the curve. That's what we call this the mean value theory of the, the integrals here. It's kind of like makes sense, right? So let's compare, right? We learned in the calculus 1, we say the mean value theory for the derivative. So what is the mean value theory for the derivative? For the derivative, okay, so let's try to review what we means here. If you still remember, in the calculus 1, we say mean value theory for calculus, for the calculus, for the derivative, we say this is the A and the B, all right? So let's see here, if I have a function go, let me exaggerate here, go like this, all right? So go like, I want to have a little bit more curvatures. That's better, or let me give a little bit more curvatures here. All right, so this one is good. All right, so this is my f of x. All right, so the mean value theory for the derivative, if you still remember, we said here, so this is a, right? So this height will be f of a, and this height will be what? This height will be f of b. So if you connect these two, whoops. So if you connect these two, what are we going to get? This is what we call is the secant lines, right? So we know the slope of the secant lines here. So let's say the slope of the second line. Okay, so what is the slope of the second line? So the slope of the second line is rise over run. So the rise will be FB minus F of A and the B minus A, right? So the mean value theory of the derivative, we say, hey, if you have here, I'm going to find a point C here. So this is the point C. So the mean value theory of a derivative, let's say there exists a C. And what is this C special about? It said, well, if you find that the tangent line goes through this C, you will find this tangent line parallel to this second line, right? So we know what is the tangent line. So what is the slope of a tangent line? Is f prime x. So this is the slope of the tangent lines, right? So that's why the mean value theory of the derivative is say there exists the C. Then if you find the tangent line through the C's here, then the slope of this tangent line will be equal to the slope of the second. So basically it's telling you that f prime C is equal to what? So it will be equal to like so it will be the equal to this is will be the B f of B minus the f of A and the B minus A, right? So that's what we say here. Okay, so now let's take a look. What is the relation for the mean value theory for the derivative and the mean value theory for the the integrations here. Okay, so now let's do a little bit like in here. All right, so now I'm just moving this one here. So this is B minus A. So this is F prime C, and so in here, so this one's here, this will be F of the B minus F of A here. All right, so now instead of, so I can use any secant, doesn't have to be here, right? So now I'm taking the integration on both sides. I can okay, so now I'm taking the integration for both sides. So this is B minus A. The F prime, you will be what? You will be, take the integration, will be the F of the C here. So what is this FB minus F of A here? So this is by the fundamental theory of the calculus. So we know this one's here is really what? So this one's here, this will be you integrate from the what? From the A to B here, right? So you integrate from the A to B, and then you kind of say this is f prime x dx, correct? Right, so this is f prime x dx. Did you see? It's exactly the same, right? It's like what we have over here. Okay, so in here, let's see here. I'm sorry, I shouldn't. So it's f of x here. Okay, I think maybe that let's try to use different notations. Maybe will be better here. All right, so let me try to use different notations here. Maybe that will explain better. Okay, so now, okay, so this is what we talk about in the fundamental series of the mean value series for the derivatives here. Okay, so now let's take a look here. The mean value series, about the integrals, right? So we have here. So from the previous one, we say f of the b, f of x dx is equal to f of the c, b minus a. I like to kind of derive from the other end, right? So maybe it's easier to see you match here. Okay, so now I take the derivative of both sides here, right? So when I take the derivative of both sides, so by the fundamental series of the calculus, we know, so this one's here. So if the f prime, I have the function f prime is equal to the f. So by the fundamental theory of the calculus, so what is this one? This will be what? This will be the f of what? This will be the f of the b minus f of the a, right? And then when you take the derivatives here, so this ones here will be f prime, the c, and the b minus a here, right? So from here to here, you know, the reason why this one is equal to this one, this is by the fundamental theory of the calculus, right? So you see here that exactly match the terms here is f prime c. Right now my f prime, you know, if you get confused, you just think about your f prime and this f prime is the same functions here. So that's why the, you know, the mean value theory of the derivative is exactly the same as the mean value theory of the integrals here. Okay, so now let's kind of extend this concept to see and what we can do about it. So here they say mark the functions, right? So we know there is, so we can guarantee there's a C to satisfy the mean value theory of the integrals here. So what that means here, so we say, okay, so that means that I probably have a C in here. So remember the mean value theory of the integral, that means I'm use this C to create a rectangle. So this is my rectangle and the width of this is f of the C, right? So basically this one's here. So the C, the f of the C times b minus a is going to equal to the value, the area under the curve. So the reason why I choose here, because this little triangle, kind of a triangle here is above this rectangle, and this little triangle, the kind of similar like triangle, not really triangle, that a curve is below these things. So these two cancel. So that's why we say the, you know, this areas here will be equal to, you know, the whole areas under, you know, the curves here. That's what we mean here. All right. So now let's take a look. The next ones here, they said the f of x is equal to the x squared. So how do I find the C satisfy the mean value theory of the integrals here? So I say, okay, so the x squared for 1/4, the dx, I want to find the total areas, right? So the total area, this would be x cubed over 3 and the 4/1. So it will be 21, right? So I know this is the total area. So let me color that. So this is the total area under the curve. So I know the 21 has to be equal to some function C times, you know, the times the length of this curve, the interval is 4 minus 1. So it's 3 here, right? So I know the f of the C has to be equal to 7. That means this height here has to be equal to 7. So where is the C value? So I know the C values here will be C squared equal to what? Equal to the 7. So the C is equal to the square roots of the 7. All right, so I know when you take the square roots, it will be plus minus, but the minus is not going to be satisfied in the 1/4. So for these functions here, Okay, so for this function, so this is the x squared, x equal to 1 is 1. Okay, so this 1 and the 1, so here the 4 is 16. So it's something like, right? So like this is a fourth here. Okay. So basically we say, okay, this is the from the 1 to 4. Okay, so we find the overall, this is the integration, so this is the total, right? So this is the total area under the curve is 21 here. So the square roots of the 7 is equal to 2.64. So that means 2.64. So somewhere right in here, this is the square roots of the 7. So if you do that, right? So then we know, of course, maybe my graph is not too accurate. So that means this red, purple, the rectangle, the area of this purple rectangle will be equal to the yellow, the integration regions here. All right, so that's it. So this application is quite simple. So basically, it's just very interesting. You can see the mean value theory of the integral and the mean value theory of the derivative. They really talk about, they are the same formula. It's really pretty cool, right? So like you can see the relation of each other. All right, that's it. And so that's why we finished the first unit. And so cannot wait to go to our second unit. We're going to talk about all the different integration, the skills. All right, nice talk to you. Have a good day. Bye-bye.